Welcome back, Swell Academy students. Today we're talking about proving how to how a triangle has 180 degrees, and what we're going to do to what geometry pieces we're going to use to prove that are our parallel lines and angle relationships along a transversal. So let's first look at two parallel lines. We're assuming that infinitely in each direction, these lines are not going to intersect each other. And then we're going to go ahead and provide a transversal for our two parallel lines. Call it N, M, and O. They like to use those letters for lines, not sure why. So let's just start by adding an angle in which we don't know the measure, but we'll call it angle x degrees. We have no really idea of how many degrees it is, but we're going to call it x degrees. Now, remember when we discussed parallel lines and transversals, you have these angles called alternate interior angles. And alternate interior angles along a transversal are congruent. So if this is angle x here, we could say that this is angle x here. Okay? Now let's draw another transversal and create another set of relationships or alternate interior angle relationships. And let's call this angle y and angle y here. Now we don't know how many degrees angle y currently has, but we do know that both of these have the same measure or degree. Now, if you're beginning to see hopefully you're beginning to see the mystery or little magic, let's call it magic, that's being revealed here, is that it looks like we're creating, if I were to fill in this little piece of pizza or missing part of this angle here, it looks like we're creating a three angles that form 180 degrees because these three angles form a line. So the idea is if I had a circle and I had a center and I drew a line to the center of that circle, anywhere in that circle I drew a line, the result is going to be 180 degrees. So if I have this half circle here along this line, and let's say I call this angle Z, well then I could, by definition of a line, I could say that x plus y plus z is equal to 180 degrees. Now, these three same angles that I'm saying are 180 degrees, well, why don't we take a look at the same thing that was formed, let me get a good color here, our triangle here. Let's make this a little bit thicker. Here, if you see, a triangle has been formed with angles x, y, z. And since we know these three angles add up to 180 as far as a linear pair, well then we're going to have to assume that these three same angles, z, x, and y, these three angles that form a triangle also have to be 180 degrees. So basically what we've done is we've used parallel lines to create a linear trio, let's call it. And because we have a linear trio, we know those angles are 180 degrees. We could also assume that being y is congruent to y, let's use a congruent symbol there, and x is congruent to x, we could assume, and z is, that same location of angle, we can assume that this triangle here is also 180 degrees. So it's a cool little proof. This is probably the simplest or easiest to understand. If you know parallel lines, how to show, prove, demonstrate that a triangle will always and forever, always have 180 degrees. So thanks for stopping by, and remember, hard work brings success.